Hello everyone and welcome to SimpleRockets2. Today I'm trying to use SimpleRockets2 to detect or simulate the solar analemma. This world of SimpleRockets2, it has a star resembling the sun, and it has a planet. It's called Drew. It's not Earth. The whole system is not like the solar system, like the sidereal day for this planet is 14 hours. So we're not going to get the solar analemma through the existing system. So we will have to create our own system. So I put this satellite here in an orbit, inclined by 23 degrees to the vertical or the axial spin axis of this planet. And let me show you the orbit information here. The period of the satellite, the orbital period, is 14 hours, and the eccentricity is 0.002. There is no more accurate input or output for the eccentricity in this simulator to make it the 0.0167, that of Earth around the Sun. The inclination is 23.2. I wanted to make it 23.4, but it's close enough, and it's really pain in the ass to adjust these things. The right ascensions, never mind it for now. The Argument of Perigee is 130. This is important because if this is the sun here, and this is the orbit of the Earth, of course the Earth axis will be vertical like this here. So this would be the winter. We have, let me show you these arrows. You see this up and down arrows. These are the ascending point and the descending point of the orbit. Yeah, I think you can see them. So starting from the ascending orbit, if you measure 183 degrees, you reach to the perihelion or perigee of the orbit, and that's exactly what's the case of the Earth. And let me show it here. Maybe from another angle you can see. You can see that here is the ascending node, and this angle is more than 90 degrees. So the first 90 degrees is here, and right here is when the winter solstice, and 13 days later that's the perigee. So the winter solstice is when the Earth is at its highest point in the orbit in relation to the Sun, if the orbital planet itself was tilted, not the axis of the Earth. So the axis of the Earth will be vertical as it moves in this orbit. So now we move to observing the solar analemma. I have another ship on Earth, or on Drew. Let's go to that ship. So this is the ship here, and it's just dark, you cannot see it. So we want our observation to be towards the south. So we make the heading south, and we look in that direction. We zoom out as far as we can so that our field of view can contain as much of the space as possible. Now we go back to map view, find our ship. Where is it? And we select it for dragging. Go back to the map view. Yeah, here it is. This is the ship. see the moon. Now all I need to do is to move the time lapse, make it faster. And as you see now, the analemma is taking place. Now let's switch to making something like the star trails of the analemma or analemma trail.